I'll talk about how do you build media pipelines to basically record video calls. So I'm from a startup called Dite. We basically give a video and audio calling SDKs for you to integrate calls into your app. So this is one of the features I worked on in Dite. So what will we go over in this talk? So I'll talk about three approaches we sort of iterated over at Dite, things we learned along the ways, pros and cons of each approach that we found. And also, finally, which approach I think is the best to use for each use case. So yeah, so first let's try to figure out what is exactly recording. So according to me, a recording is basically on the high level a sequence of 3 steps. So the first step is capture. So capture is figuring out what parts of the video conference basically you want to record. So it might sometimes be just video audio, but it can also be things like chat, for example, right? So the second step is transcode. So it's about taking this raw video and audio data and transforming it into a format that is easier to store. And the third step is storage. So yeah, storage is about where do you store the file, and it also will matter on how do you serve the file in the end. So if you want users to be able to download this file easily, so you would pick a storage which basically supports that. So yeah, and for each of these blocks, you have sort of many choices. So we had clients which came and told us, hey, we have a use case where we have 2 people on a call, and we want videos of each person as separate files. So I want peer A.mp4 and peer B.mp4 as 2 separate files. The most common use cases, of course, most clients want to record the whole video as one grid. So they want the actual UI, what you see when you enter the call. And also in the storage type, the most common use case we see is to store to a file in multiple formats. Of course, if it's audio, it might be MP3 or MP4 for video. Some clients want to stream to a third-party platform. So it could be YouTube or Twitch. And also, we have our own live streaming infra. So we also sort of reuse our a pipeline for also that. So yeah, so let's go over the ways you can sort of tackle all of these problems. So the first iteration we did was right when we started. So we didn't really know about the whole space yet. So we learned about, so I call this approach client-side recording. So there's this API on the browser called a media recorder, which basically gives you really easy to use interfaces to record media. So you can pass this any kind of media stream object. So it could be from a canvas, it could be from a raw video audio track from your SFU. So, and it supports a few video encoding options. So you can set the MIME type, you can have a WebM with X264 inside it, or VP8 or 9. And also you can set the video and audio bitrate. So yeah, you have a few options to basically tweak. And this happens on the client side. So basically it's this JS API, which runs in the context of the browser. So yeah, I've linked the docs for the API. We'll just go over how this looks sort of in code. So yeah, I have I make a call to get media, which will basically get the screen share track for the user. So you might have like seen on Meet, for example, when you click share screen, it shows that prompt where you have to choose the screen which you want to share. So this is basically that step. So once you do that, you get the media stream, and then you can simply pass this to the media recorder API. You can attach a few callbacks to basically get the final video that was recorded. Yeah, and in this example, I sort of just make some kind of link for the user to download that video on their browser. So yeah, if you want to visualize how the end-to-end flow sort of would look like, so you would have some kind of record button on your browser, and yeah, as I said, a prompt would open up, and you would use the APIs I showed on the previous slides to basically record the media, and then you get a file which you send to your storage. Yeah, and one very crucial part which sort of affects where you can use this approach is that it runs on the client side. So for a normal video conferencing application, since you have multiple peers joining a meeting, if you do the recording locally, you get these multiple sources of truth for what gets recorded, because you're doing it on every peer's context, right? So, and you have issues like if the peer drops out of the meeting, you basically lose all the context. So I would say it's, I will also go over where you can use this approach, but yeah, that's something to keep in mind. So yeah, let's talk about the good and the bad about this approach. So first of all, it's really easy to build. If you want something fast and easy, you can use this. So it's completely on the client side. There's absolutely no server cost. That's if that's something you want, you can use this. There is no extra bandwidth required for download because it happens completely on the client side. It's already on your browser. And one cool thing, obviously, since you're working on the browser context, you get access to CSS and JS APIs, so you can easily sort of build layouts using those to show things in the recording. And you can use HTML5 canvas, for example, to generate a media stream track. Yeah, and the bad part, I think the first thing I already went over, if the browser sort of crashes, you don't have any recording. One thing I think that was mentioned in one previous talk as well, so the media recorder API basically stores the video chunks on your browser's RAM. So this is bad because as the length of the recording increases, it will take more and more RAM in your browser, so that's not ideal. And also you have limited transcoding options. So one of the issues we saw was certain players, like for example, a QuickTime on Mac, they may not be able to play this video in the right way for all kind of cases. So yeah, so that's when we sort of tried to mess with this approach a bit. So we tried to move these APIs, but to the server side. So the idea was very simple. You run like virtual Chrome browsers on the cloud, and you basically you can use any sort of hosting like VM on some a cloud platform like K8 or ECS or Cloud Run. So yeah, you run the browser there and you join the meeting, and then you use the media recorder API there to basically record the browser. So the benefit is, of course, you sort of move away from all of those client-side issues I talked about, where sort of if the peer drops or drops from the meeting, they will not be basically there won't be one source of truth for the recording. So, but there was one thing we had to handle. So I talked about that screen share prompt that shows up when you record the screen. So we actually had to use a hack to sort of go around that. So Chrome extensions, yeah, so that was the prompt. So Chrome extensions have access to this special API where you can directly access the stream from the tab. So you don't really need to show that prompt, right? And since in this use case, we are running our own browser on the server, we can pre-install this Chrome extension on the browser and use these APIs. So yeah, for example, in this code sample, I sort of use chrome.tabcapture to get the stream of what the tab is showing. And then I can use the same approach to pass this to the media recorder APIs and to record the screen. So yeah, the good part is, of course, from the previous approach, since it's now on the server side, we can sort of handle more things on there. So if the browser, for example, crashes, we could restart it if that's the approach. So yeah, and it's still easy to build. So you didn't really get into the mess about video transcoding because the media recorder API handled all of these things for you. The bad part is this. So Chrome takes a lot of RAM. So by our readings, even to do a 720p recording with the media recorder API, you need at least 4 cores and 8 GB of RAM per recording. So yeah, so if you had like 1,000 recordings running on your service, it would be 4,000 cores, which is a lot. So that's sort of one bad thing. And one thing I think I missed is, yeah, the transcode options are sort of limited. So we'll also talk about how to solve that. So yeah, so the second approach we sort of migrated to because it was an easy migration was the idea was simple. We don't use the media recorder API, but we use our own transcoder based on FFmpeg to basically capture the screen of the browser, right? So the main benefit is we sort of get more of these granular arguments we can pass to the encode process, which can help us tweak these small things to make the process faster. One thing we could also do to make the service more reliable is sort of save these particular segments of videos while the recording is going on. So, and we could save these in some shared storage. So this was really helpful because if the process did crash, we would still have these segments and we could sort of re-invoke that recording somewhere else on some other VM and then sort of re-record segments from that point. In the end, we can just join all of these. So yeah, that was what I just spoke about. So you have an X11 server running Chrome on your VM, and you have a pulse audio, which will capture the audio from the browser. You can use a FFmpeg to sort of read these video and audio tracks, and then you can transcode it according to options you pass, and you get segments out, and you can finally join all of these segments to get your final recording file. One thing I should talk about here is how do you scale something like this on the cloud? So spawning a VM on the cloud, and this also matters on what's the sizing of the VM and what you're using. So, but on general, it takes about 40 to 200 seconds. So this is not ideal, of course. So you can't have an approach where you start a recording and then you spawn a VM. So of course, one good thing to do here is to maintain a pool of free machines, and then you sort of make the recording go on those. So that will speed up your process of starting recordings. And at Diet, we had this sort of high-level structure of how we handle this. So we had this master process where you can send a recording task to this worker. So we had a pool of workers always running, and we had a scaler which would scale this up and down based on various data fields. So it would see how many recordings are active, how many meetings are active, so on, right? And yeah, and we upload the segments to a bucket. So, and then you can sort of access those segments later and join the recording into a final video file. So yeah, the good part about this is if you tweak those options on the transcode process well, you can actually get the usage down all the way to 2 cores. So that is again for a 720p recording. So yeah, that's something we could use to reduce our server costs a bit. The bad part is you have to still suffer this extra overhead of running Chrome. So in this whole process, we have to still run a Chrome browser, even though the actual thing we're trying to achieve is just to record video, right? And it's sort of limited to screen capture. If you use the approach I said, you could get around this by sort of transporting the raw tracks to your encoder, which will be the next approach I will talk about. But yeah, it would require extra steps. So yeah, and the third approach, and it's something we built I think a month ago, is to sort of directly process these video packets, all the streams from your a media server. So you can directly process these, and you can use a tool like a GStreamer to basically build your whole media pipeline where you transform these packets and route it to various places, right? So one thing to note over here is this scales on a per stream basis. So it's not like something per browser anymore. And you could, of course, use this along with the other approaches we spoke about. So you could hook it up to any kind of audio video source in your whole infra. So yeah, a small intro about GStreamer if for the people who haven't used it here. So it has these bins, which are basically simple sort of building blocks for media pipelines, and you can also build your own bins. So we also built this sort of bin to a mux video on this kind of a grid, so you can have it on the recording. So yeah, this is an example GStreamer pipeline. So you have your SFU here, which you sort of route the video audio packets from there to your GStreamer pipeline. And you can use bins like RTP bin to sort of parse this packet into multiple RTP sessions. And then you can decode the audio packets from it using the Opus decode payload element. And finally, there's this really handy element called T, where you can sort of branch out this track to whatever you want to do with this audio file. So for example, you could use Audio Mixer to sort of mux all the audio as one file, or you could store it in a file directly, or you could encode it into some other format, right? So yeah, scaling on the cloud here is really similar. So you can have that same master worker approach I spoke about. Of course, now you scale on a per stream basis. So I can route, I don't need to route streams onto the same server. I could route them to more than one server. So you have that new feature. And yeah, for the use case of recording raw tracks, so I talked about that on the second slide. So let's say a client wants separate tracks for each person on the call. You can almost do this at zero cost. So it's basically just taking already a video sent from the browser and just dumping it in a file. So yeah. Um, so yeah, the good part about this approach is you have no overhead of sort of running Chrome. It's really low CPU usage. Uh, Recording, as I said, individual tracks is very efficient. And it's really flexible on what you do with this video and audio. So as I said, I could stream it somewhere else. And the main benefit is I just need to read the packets once, and then I can route it anywhere. Of course, you might need to still transcode more than once based on what the client wants. So yeah, and the bad part is to write anything which is not there, as you know, a GStreamer plugin uh, already. You'll have to sort of go into their docs and figure out how to handle this complex video transcode process. Of course, if you have the manpower to do it, you should, because it is the best approach, I would say. But yeah, that's just something to think about if you're looking for a fast POC versus something that requires more effort. Right. So which one do you use? So I would say for any use case where you need to record really short clips on the client side, I would say it's okay to use the media stream recorder API as long as you know about those client side faults and you're okay with them. Uh, if you need any kind of a use case where you need to record a browser web page or some sort of grid layout with a complex UI, then I would say the cloud browser approach has some kind of a merit because CSS and JavaScript do let you create nice to see things. So as opposed to dealing with really low level APIs, which might take more work. And of course, if it's some kind of browser web page, you have to basically run some kind of a browser. And yeah, if you are recording individual tracks, or if you have really simple sort of grid layouts where you want to show the recording, the best approach would be to use the stream-based recording and to build your own pipeline on top of that. So yeah, that's my talk. Thank you. And if you have any questions, you can.
Any questions? Questions? If not, we can maybe. Yeah, one question.
Thanks for the talk. I think it was very comprehensive. We followed very, very similar path. I wanted to share a trick with you. In approach number 2, one of the reasons why Chrome takes time to start is because it needs to build a profile. Yep. So when you build the image or the container, you can run Chrome for 1 second, and then the profile is built, and then it starts up in like 1/10 of the time.
Okay, that's interesting. So, yeah. In our use case, like we sort of would pre-scale these browsers. As I said, so we would have like a pre-built pool of sort of Chrome browsers. So we didn't really need to think about the startup time of Chrome. So it would be an already loaded Chrome browser, and we just pass it this meeting to join. So yeah, but that's really interesting. For sure, it would speed up our startup times.
Yeah, thank you for the talk. I wanted to ask, because you mentioned GStreamer and FFmpeg, did you make a comparison in terms of utility, in terms of memory usage, or did you just choose it because of familiarity?
So in terms of CPU and memory usage, I would say it's similar. FFmpeg is slightly better, but the thing is, GStreamer gives much better, I think, APIs for you to build pipelines. So FFmpeg is slightly more complex to use, I would say. So in terms of the dev experience, I would say GStreamer is a better sort of library. But if you really care about that small amount of CPU usage that you save, FFmpeg might hold some merit, So